Okay, let's dive into an invisible world that's happening all around us all the time. It's this constant, kind of chaotic dance of particles. And while you can't see it, as we're about to find out, you can definitely smell it.
I mean, seriously, have you ever stopped to think about that? Why does a smell, and it can be a good one, like popcorn or a not so good one, never just stay put?
Yeah, it's like it has a mind of its own. That smell just wanders off, spreading out until it's filled every single nook and cranny of the room. But what's actually making it do that? What's the engine behind this invisible spread?
Well, the culprit has a name: diffusion. It's really just the gradual movement of particles from a place where they're all bunched up to a place where there's more room. You can almost think of it like particles wanting a bit of personal space. They're trying to escape the crowd. So to really see this in action, we kind of need to watch it in slow motion. So let's start by uncovering some evidence for this whole great escape idea, but in a simple beaker of water. The setup here is super simple. First, you just start with some plain old water. Then you carefully drop in a single tiny crystal of something called potassium permanganate. And the most important part, you don't stir it, you don't shake it, you just watch. And here's what you'll see. That super bright purple color starts to slowly bleed into the water. Those little purple particles are literally weaving their way in between all the water particles. They're spreading out or diffusing all on their own. Now, this isn't some kind of magic trick. What you're seeing is just the result of pure, random motion. All the particles, both the water and the purple ones, are constantly jiggling and bouncing around, and all that chaos is what eventually causes them to mix together perfectly. All right, so that's how it works in a liquid, which is pretty slow. But what about gases, the stuff that actually carries smells? Does diffusion happen with them? And here's the interesting part. Are some gases faster than others? To figure that out, let's set up a little race. We're going to pit two different gases against each other and see what happens. Here's our racetrack. It's just a long glass tube. At one end, we've put some cotton wool that's been soaked in ammonia, and at the other end, we've done the same thing with hydrogen chloride. They're at the starting blocks, ready to go. So both of these invisible gases are going to start spreading out, moving towards the middle of the tube. The big question is, where are they actually going to meet? Your first guess is probably right in the center, right? Well, check this out. Where the two gases meet, they react and create this solid white ring. That's our finish line. But look, it is not in the middle. It's way closer to the hydrogen chloride side. So what does that tell us? It all comes down to their size and weight. Turns out ammonia particles are a lot smaller and lighter, so they can travel much farther in the same amount of time. The hydrogen chloride particles, on the other hand, are bigger and heavier. They're the slow pokes in this race. So the lighter, quicker ammonia particles totally win the race. They zoomed way down the tube before the slower hydrogen chloride particles had a chance to get very far. So from purple water to a race between invisible gases, we've seen this unstoppable spread in action. So what's the one simple rule that explains everything we've just seen? It's this right here. This is the fundamental law. Particles just tend to spread out. They move from crowded areas to less crowded areas. That's it. That's the big secret. And that brings us right back to the beginning. That's why a bad smell eventually fills a whole room. The particles are just following this one simple rule. And it's not just smells. This process is happening constantly, everywhere, all around you. Which, of course, leads to this very relatable thought. If only knowledge worked the same way, right? If you could just sit next to a textbook and have the information diffuse into your brain. Unfortunately, I think we have to work a little harder than that. So from now on, when you smell coffee brewing from the other room, you'll know exactly what's going on. You'll know all about the invisible forces at play. Which leaves me with one last question for you. What other invisible movements are shaping your world right now?